This is the Particles Homework Booklet question 37, and we're asked initially what phenomenon can be used to demonstrate the wave properties of electrons. So that would be electron diffraction. They also accepted electron interference. We're then asked to calculate the wavelength of the electrons travelling at a certain speed. Again, very, very straightforward here. We're just using lambda is h upon mv. Again, h from the formula booklet, m the mass of the electron from the formula booklet, the velocity from the question, run it through, we get 2.9 times 10 to the minus 9. These two bits of data I have got to 3 significant figures, but the velocity is only to 2 significant figures, so I'm going to give the answer to 2 significant figures, and on this occasion there was an independent significant figure mark for that. So moving on to part C, and we're asked to calculate the speed of muons that have got the same wavelength as those electrons. We're given a bit of information that the mass of muon is 207 times the mass of electron. Well, if we're after the same wavelength, because the wavelength lambda, I've got the formula here, because lambda is h upon mv, if I want the same wavelength, I want the same mv, the same momentum. And if I've got the mass being 207 times bigger, then the velocity has to be 207 times smaller. So I can simply take the speed we had previously divided by 207, and I get my answer again, 2 significant figures here, 1200 meters per second. The alternative, and probably the more obvious way of doing it, but slightly more clumsy, would be to have used that wavelength that you'd got in part B, use lambda is h over mv, rearrange it, multiply both sides by v, divide both sides by lambda, v is h over m lambda, and if you'd crank that through the calculator you would also have got to that 1200 meters per second. So that is Particles Homework Booklet question 37.